Okay, a little bit faster now for number 2. Okay, I only have one side length, so I can't use Pythagorean Theorem. This is not one of our special right triangles, so I have to use trigonometry. I'm going to use what's printed, and I'm going to label my sides using that vernacular: opposite, adjacent, hypotenuse. This is my hypotenuse, this is my opposite leg, and this is my adjacent leg. From there, we need to solve one variable at a time. I'm first going to solve for A, because alphabetical order. So this is my opposite leg, and I have my adjacent leg. That's how you determine what trig function you're going to use. What do you know? What actual length do you know? And what length are you searching for? So what trig function involves your adjacent and opposite leg? Tangent. So that's how you choose your trig function. Tangent of 39 is equal to, if you look at your formula chart, tangent, that ratio is opposite leg divided by adjacent leg. So for this example, it is A divided by 6. Put your trig function over 1, cross multiply. Once again, when we take the cross product, the variable is solved for. This will not always happen. But A is exactly 6 times the tangent of 39. Someone that typed this into the calculator already, what is it? I'm sorry. 4.9. 4.9. You all agree? 4.9. Wonderful. Next one. Again, if you have questions, you need to stop me. The next one. I've got what A is, but I'm still going to use what is printed. I'm still going to use 39 degrees. I'm still going to use my adjacent leg, that's 16 units. Or sorry, 6 units. And now I'm going to solve for my hypotenuse. So we need to figure out what trig function we're going to use to solve for the variable B. Which trig function involves hypotenuse and adjacent leg? What is it? Cosine. So cosine of 39 degrees is equal to, if you look at the formula chart, cosine is adjacent leg divided by hypotenuse. So we got 6 divided by the variable B. When you're solving for side lengths, you put the trig function over 1, you take the cross product. So for this, we're going to get B times cosine of 39 is equal to 6. So right now what's happening to my variable is that it's being multiplied by whatever this value is, cosine of 39. So we're going to do the inverse operation with that same exact value. The inverse operation being division, that value being cosine of 39. So my exact answer, because on the left-hand side of the equation I get just B by itself, and over here I got 6 divided by the cosine of 39 degrees. This is my exact answer. 6 divided by cosine of 39. When you type that into your calculator, what is it, the estimation? 7.7. Fantastic. These answers make sense because the hypotenuse should be the longest. We don't get negative values. If you get a negative value for a side length, that should be a red flag. And then also just make sure that they make sense. Your hypotenuse should be the longest. The shortest side should be opposite the smallest angle. So just make sure your answers make sense before you move on to the next problem. Please ask questions if you have them. Okay, I told us that we're going to skip number 3. It's just more like this. It's just more like this, using your normal trig functions. And so you'd have to use tangent to solve for z. It would be tangent of 50 is 11 divided by z. To solve for x, you would have to use sine. Sine of 50 is equal to 11 divided by x. Number 3 is just more like 1 and 2. But I want to get into different problems. Number 4. On the test, when you approach a problem like this, again, you need to go through it. Okay, how am I going to solve this right triangle? Can I use Pythagorean's theorem? No, because I only have one side length. Some of you say yes, because these are the same. That's fine, it'll take you longer. But if you want to use Pythagorean's theorem, you actually technically could. But we're only given one side length, so we're going to go to the next option. Is this one of our special right triangles?
Yes.
Yes, it is. This is one of our special right triangles. It is a 45, 45, 90. I know that because if those two angles are congruent, then they're taking up the same amount of degrees that's left over after you take away the 90. So 180 minus 90, we have 90 left over. 90 divided by 2 is 45. So yes, we can prove, we can convince ourselves that this is a 45, 45, 90 triangle. The extended ratio, the thing that I'm going to write immediately after the angle measurements, is L square root of 2. L standing for the leg, the length of the leg. So on a 45, 45, 90, that's a right isosceles triangle. So we know that our legs are going to be the same exact length. And just how the side lengths are related to each other, you take whatever that leg length is and you multiply it by the square root of 2. So I'm going to plug in what I'm given. I have been given that the hypotenuse is 10 units long. And I circle both of these because that is my equation. That's the equation that I need to write. And so, off to the side, I need to solve for L. I need to solve for L. Because what I know right now is whatever L is, that variable, when I multiply it to the square root of 2, apparently I get out 10. I have that the hypotenuse length is 10. And so that is this. I'm just setting these two values equal to one another. So from there, I need to get the variable by itself. It's currently being multiplied by the square root of 2. So you need to do the inverse operation, which is division, with that same exact value. So I need to divide by the square root of 2 on both sides of the equation. So the length of my leg is equal to, technically, 10 divided by the square root of 2. That is the correct value. But that's not a proper way to represent this value. You can't have a fraction with an irrational number in the bottom. You can't have a radical down there. So we need to rationalize the denominator. We just need to get it out, get that radical out of the bottom. And we've discussed that the way to do that is multiply top and bottom by whatever radical is down there. So for this example, we have the square root of 2 that is the denominator. So I'm going to multiply top and bottom by the square root of 2. We know how to multiply fractions. We've known that since primary school or elementary school. So we have multiplying fractions straight across. Multiply your numerators. 10 times the square root of 2. Literally. 10 times the square root of 2. On the bottom, I've got the square root of 2 times itself. So the square root of 2 times the square root of 2 is the square root of what? 4. It's 4, right? Square root of 2 times the square root of 2 is the square root of 4, because you multiply the numbers that are on the inside, and if there are numbers on the outside, you would multiply those together. So this equals the square root of 4, but we all know that the square root of 4 is just what? 2. That's the whole reason we do this, because we want our denominator to be a rational whole number. So now, the way that I look at this is, I've got 10 of these square roots of 2, whatever they are. I've got 10 of them right now. But I only need half. So when I take half, those things that I have, that I had 10 of, they're not going to change into something else. I just now have less of them. So when I take half of 10 square roots of 2, I'm going to get some certain amount of square roots of 2. So what is half of 10? 5. It's 5. So I have 5 of these square roots of 2. So that all that work was for L. So L is 5 square roots of 2. So that's what you would plug in. And so we have solved this. So both Q and R both equal 5 square roots of 2. We have questions about number 4. Number 5. Can we use Pythagorean Theorem?
No.
Is this one of our special rights?
Yes.
Yes, it is, because this is 90 degrees. That's 60 degrees. So by using the triangle sum theorem, that is 30. And then I notice, oh, hey, this is a 30, 60, 90 triangle. So I'm going to write the degrees in ascending order, 30, 60, 90, so they're getting greater. 30, 60, 90 triangle, and then immediately below that I'm going to write the extended ratio that these side lengths follow. That is L. L square roots of 3 and 2L. L being the length of the shortest leg, which is opposite the 30-degree angle. From there, once you write the angle measurements and you write the extended ratio, from there, you look at the diagram and see what you're given. We're given the side length that is on the other side, that is opposite from the 60-degree angle. So you plug that in. 9 units is this, right? Sorry, I don't know why I wrote 6. All right. The side opposite the 60-degree angle is 9 units. I walked around and saw that some of you added to this. You can't just add whatever you want. You can't add the square root of 3 to this. I gave you that it was 9 whole units. So that is what you plug in, period. It's 9 whole units. So after that, once I plugged it in, you circle them. That is your equation. You set those two things equal to one another. So off to the side, I've got L times the square root of 3 is equal to 9. Now remember, your formula chart uses x as the variable. That's fine. It's just a variable. You can use your favorite letter. I don't care. You can use Z if you want to instead of L or instead of X. You can use R or Q, W. Doesn't matter. Okay? I just use L because that stands for leg, the length of the short leg. Anywho, this is what I'm given, so I set them equal to one another. And now I need to solve for the length of the short leg. Everything goes back to the length of the short leg. Because once I find this, then all I got to do is double it to find the hypotenuse. So, currently in this equation, my variable is being multiplied by the square root of 3. So I got to do the inverse operation, which is division, but with that same exact value. So I'm going to divide by the square root of 3. On the left-hand side of my equation, I now have my variable all by itself. It's solved for. Equals to 9 divided by the square root of 3. Now technically that's the correct value. We can't represent the fraction like that. So we need to rationalize the denominator. What am I going to do?
Multiply the square root of those 3.
Multiply top and bottom by the square root of 3. We're multiplying by the square root of 3 this time because that is the value that's in the denominator. That's why. So multiply top and bottom by whatever the denominator is. So, from there I'm going to multiply straight across. This is 9 times the square root of 3. That's what's on top, my new numerator. On the bottom, I've got square root of 3 times the square root of 3 is what? Most simplified form? It's just 3. It is just 3. Because the square root of 3 times the square root of 3 is the square root of 9. And we all know that the square root of 9 is just 3. That's the whole reason we did it, so that now this is a nice, pretty whole number on the bottom. However, we can still simplify this fraction. I've got 9 of these square roots of 3 right now, but I only need 1/3 of it. That's how I look at it. I need 1/3 of whatever's up on top. Okay, well, so when I take 1/3 of this, I'm still going to be left with a certain amount of square roots of 3. I'm not changing what I have, I'm just changing how many that I have. And so, I know that in the end, it's going to be some amount of square roots of 3. How many? You divide your coefficients. Just like when you multiply the numbers on the outside, and you multiply the numbers that are inside. Well, right now, there are no numbers on the inside that I can divide. So it just stays square root of 3. But 9 divided by 3 is 3. So my new coefficient is 3. And that is the length of my short leg. Questions on how I determine the length of the short leg? Okay.